for this, it's kind of fun to tell maybe a bit of like a Batman origin story. Everyone loves a good superhero origin story. Like we thought that GitHub servers were going to go down.
Hi, I'm Lahini Arunachalam. I run the Founders Hub platform team for Microsoft for Startups. And today I am joined by Ryan J. Salva, the VP of Product at GitHub. Welcome, Ryan.
Hey, how's it going?
Great. How are you?
I'm staying pleasantly busy. Yeah, thank you so much for having me today. I really appreciate it.
Of course. We would love to hear a little bit more about you and your background and what you do at GitHub.
Okay, yeah, sure. Yeah, as you said, my name is Ryan. I'm VP of Product at GitHub, where I've been knocking around for about 4 years now. I came really just after Microsoft had acquired GitHub. And in that time, I've run just about every part of the GitHub platform. So everything from enterprise and infrastructure and identity to GitHub code spaces, pull requests, ecosystem, data platform. But a lot of my last 3 years in particular have been about GitHub's AI strategy, of which GitHub Copilot is probably the best known brand name. Prior to that, about a decade at Microsoft, where at least my most recent gig had been running Microsoft's other DevOps platform, Azure DevOps. I ran that for about 2.5 years, as well as Microsoft's internal developer infrastructure teams. So what Microsoft calls One ES or One Engineering System. Think of it as like a super scaled instance of Azure DevOps that kind of underpins the engineering systems for Office and Azure and Xbox and all those other brand names that you know at Microsoft.
Yeah.
Before that, another decade at startups. Some of them other people's, some of them my own. But really, kind of the common thread through all of it, the thing that gets me up every morning and then sometimes keeps me up late at night, is helping other people create things with software. I'm a very mission-driven person, and I just love helping other people build things.
That's great. And we all appreciate that, especially because GitHub's releasing a bunch of new and awesome and innovative products. So that's great. So GitHub Copilot, that's so interesting. And it's one of the things that our developers on our team use every day. It's what our founders use every day. And from what I've heard, it just makes their productivity go up like at least 5x from what it is today.
Okay, we'll spend some time with some of those numbers then. But okay, I'm glad that it's helping you be more productive. That's good.
But would love to understand what that journey looked like to actually build the product. So can you tell us a little bit about that experience of what it was like to take something that I'm sure started as a small prototype, and how did you bring it to market and then scale it the way it's scaled?
Yeah. So, you got to remember that we started experimenting with GitHub Copilot before ChatGPT was the thing, before Stable Diffusion, before Midjourney, before any of that was really around. And it's not to say that, AI didn't exist. Of course it did. And in fact, by that point, OpenAI had kind of gone through GPT-2 and J and all these other ones, but no one had really built a SaaS product on top of these large language models yet.
Yeah.
And actually, for this, it's kind of fun to tell maybe a bit of like a Batman origin story. Everyone loves a good superhero origin story. So like my first the way that I first got acquainted with GitHub Copilot was, at the time I was running our infrastructure team, and we were having a live site incident. It's like we thought that GitHub servers were going to go down. And I don't have to tell you, when GitHub servers has even a minor availability incident, it's all over Hacker News, it's all over Twitter, it's all or X, whatever it's called these days. It's a big deal. And so we weren't quite experiencing downtime yet, but it was starting to clip up into the red a little bit. We're like, what the heck is going on here? What is going on? And okay, we did a little bit of diagnostics and sleuthing. Okay, it looks like someone's doing a bunch of clone actions on our repositories. Okay, perfectly viable use of our APIs, but when it happens programmatically again and again and again, it puts a lot of stress on the system. Well, eventually we did a little bit more sleuthing and we're like, okay, it looks like it's coming from this set of IP addresses. And then we did a little bit more investigation beyond that and got in contact with our friends over at Microsoft. And it turns out that it was OpenAI. OpenAI was essentially doing clone events on public repositories in order to, gather and harvest kind of training data. And so we eventually, through Microsoft's Office of the CTO, got in touch with them and we're like, y'all, stop it. There's a better way to do this, right? And so, we found a way to kind of, relax and kind of some of the API limits and talk to them about how they might even out a little bit of their queries so that they didn't put our system under stress. But that began some of the first kind of conversations about how we might use some of these large language models in order to address coding scenarios. We experimented with a lot of different things, like, hey, should it be the kind of thing where you ask what you want and then you get a bunch of different suggestions on the side? Actually, it wasn't very long until maybe in the first few weeks there that we got to kind of the code completion and the predictive text that a lot of folks really experienced. That was their first experience with Copilot. And it was pretty clear, even in those first couple of months, internally experimenting with it, that we had something that was really magical. What we would do early on is we would basically take business logic that was in GitHub already that had unit tests up against it. And we would intentionally strip out the internals of those functions, then have Copilot regenerate the code that was the internal for the functions or the methods and have the unit tests run up against it. And we were getting success rates of 10, then 15, then 20% as we kind of like experimented and tweaked our methodologies a little bit. And so it was clear, at least within the team, this was, by the way, this was a team of maybe 10 of us, right?
Oh,
it's
wow.
a very, very small, tiny kind of moonshot team.
Sure.
And so we're like, okay, we think that we got something here. And so we released that technical preview back in, it was like July 4th, the week of July 4th, I remember, because I was actually officially on holiday that week while we were doing the kind of the ship room and the big countdown for it. And it turns out that like within a few months, we had several 100,000 folks who had signed up for the technical preview and were using it. Within a year, we had over 1.2 million folks who had signed up for the technical preview. I never in my life have experienced a product with such strong product market fit achieved so very quickly. Usually you're fighting to get tens of thousands, if not hundreds of thousands of users over years. And this we really found quickly. The next chapter of it really ended up being like, okay, we know that we've got something here that has captured the imagination of developers. Now, how do we build this into an actual product? Because by the way, it was an experiment. It wasn't meant for scale. It wasn't meant, the service wasn't architected for millions of developers to be using it, let alone to really think about how we address all the things like the normal product stuff. How do you take care of billing? How do you make sure that it fits into existing SLAs and SLOs with other parts of the service? And so it ended up being another year even beyond that before we were able to bring it to market for individuals, and then a year beyond that before we were able to bring it to market for businesses. So it was really, really a long journey, but it all began really with an experiment. And just like every other product, you ship it internally, you see if it's got a little bit of momentum, you ship it to a group of, we'll call it like trusted customers, progressively expand beyond that as you refine, as you scale.
So tell me a little bit about, these inflection points you were talking about. So like you
Yeah.
ship it internally and you said you were having some success rates between like 10 and 20%. So how
Yeah.
did you experiment and continue to learn and iterate to improve those? And then what did that next inflection rate look like where you said, okay, we're ready to
Yeah.
expand the circle a bit and get more users utilizing this?
So the percentages that I gave there, that was the pass rate for unit tests up against, where we were populating the internals of functions.
Yeah. Yeah. Yeah.
Which is a kind of a good, we called it our test harness. It's kind of a
Hmm.
good sanity check that you use.
Sure.
We actually even continue to use that before we deploy new models, right? When we're doing
Great.
the early internal testing. But we knew that we were going to need to get much smarter about how we did experimentation and how we measured the real human impact of the product along the time.
Yes.
And so pretty quickly, while we continued to use the test harness for pre-production experimentation and testing, we knew that we had to go to in-production experimentation.
Hmm.
And so, at least for us, what it ended up being kind of the best measure of quality was something that we called the acceptance rate. This works really well for predictive text or autocomplete.
Yep.
Uh,
Yep.
it does get more nuanced when you start moving into other user experience models. So like chat is different, but let's keep it simple for now. Let's focus on predictive text, right?
Yep.
So for us, what we did is we looked at, okay, essentially what is the percentage of suggestions that are presented to developers that are accepted into code? So you see a little
Yep.
bit of gray text and the
Sure.
developer hits tab, right? So
Yep.
like, here, let's do this real quick. I'm going to go over and I'm going to share my screen just so you like see exactly what I mean by that.
Perfect. That sounds great.
Okay, here. So I'm going to start up a new file in Visual Studio Code. And I'm going to say, let's see here. So create a class to manage, let's say manage customers using, let's use a public API here. So let's say using the Stripe API. How about that?
Yep.
Right. So import Stripe. Cool. Right. So you see this gray italicized text that I'm getting here. That's Copilot. That's it giving us gray italicized text, right? So we can say like, public class, customers. And actually here, let's tell it, I don't want to be using C#. I want to be using Java. Java here, which means that we don't want using system. We'll get rid of this, right? Oh, import, come on, give me something good here. Yeah, right. So this kind of stuff. That is just the kind of acceptance rate. So I received several different gray italicized text ones here. Some of them I like, some of them I don't. And so that will, ooh, wow, gosh, that's a good suggestion there. Holy moly. Okay, wow, that's kind of cool. All right, so we'll go back off of that and back to our kind of video here. So that suggestion acceptance rate, that became kind of our headline quality metric.
Yep.
And what we found is like in the early days, like when we were first doing kind of the early technical preview, we actually were getting 20-ish% suggestion acceptance rate on first release. And by the way, I happened to work in the Visual Studio and the VS Code teams before I kind of came over to GitHub. So spent a lot of time with IDEs, code editors, and like typical IntelliSense, typical autocomplete, the kind of stuff that we as developers have had for 25 odd years. It has an acceptance rate of about 14 to 17%.
Okay.
So we knew out of the gate that we were already delivering a better developer experience than folks had before. And so what we did is we started experimenting, and about every 6 months through a variety of different techniques, we were able to inch that up to 25, then 30, then 35%. Now, you asked though, like, how did we experiment with that, right? This is actually a really interesting technical bit. So we knew that it was, when you're working with the code that is in a developer's editor, it's a very private thing. Like folks may be working on open source, the kind of thing that they feel very
Yeah.
free sharing. They might also be working on code that is very important to their organization, that they want to be very siloed and private, not do kind of
Yes.
have any risk of escape for that IP. And
Hmm.
so we knew early on that we needed to be able to experiment without actually recording any of the content in the code editor as part of
Yeah.
our telemetry. So here's what
Okay.
we would do. So in Copilot for Business in particular, we do not retain any of the content for the suggestions or the prompts. Don't retain it at all. And Copilot for Individuals, we actually do offer folks the option to share that telemetry if they feel comfortable doing it.
Hmm.
And a small percentage of developers do decide to share. I suspect that they're working in either a permissive work environment or they're working
Yeah.
on open source or hobby projects.
Sure.
But either way, we needed the ability to do these experiments completely blind to the content.
Yeah.
So what do we do? Well, what we do is we know what our formula is for assembling the prompt. We know what our heuristics are for
Hmm.
how to find relevant data inside of the IDE to package up. And so what we essentially do is we can say, hey, we have our control formula for assembling a prompt, and it gets, let's call it, it's early days, so it gets 25% acceptance rate. Then we tweak our formula for assembling the prompt, and that's our treatment group. And now we run an A/B experiment in production that says, hey, is this formula better than this formula? Oh, it turns out that our treatment formula is a little bit better. Instead of getting a 25% acceptance rate, we get a 27% acceptance rate.
Sure. Yeah.
We have a new winner. So now we then keep on going and just keep on iteratively going through new formulas. And in this way, we can blindly experiment, at least blind to the content, even if we know what our formula is for assembling the prompt. So this is kind of how we went about product improvement at the technical, at the engineering level. And we could do that at all sorts of different levels of the service. So we could do it in the way that we formulated the prompt on the client side. We could do it in the way that we maybe changed our, any of our responsible AI filters, essentially pre-processing techniques that happen on the service side to filter out toxic language, to filter out prompt injection, to inspect suggestions for code quality. So we're able to do that at multiple layers of the service and incrementally improve over time.
Yeah. That's great. How did you think about marrying some of these experiments you were doing at the technical level and the A/B experiments with like the human piece of it? So people actually using the product and their feedback, and how did you marry those two concepts together?
Yeah, I mean, the great thing about telemetry is that it tells you what is happening, right? So you definitively know our acceptance rate is higher, our latency is lower, whatever success metric that you've got there. And also knowing whether or not that has human impact is impossible through telemetry, and knowing why things are shifting, metrics are moving the way that they're moving is impossible without actually going out there and talking to customers. And so, we employ a lot of the techniques that I'd say we have with any other product that I've built. It takes on a slightly different timbre because you're working with probabilistic technology rather than deterministic technology.
Yes.
And so the conversations get a little bit more nuanced.
Yes.
So first, we're going out there and we're talking to developers as much as possible. That is in community forums like the GitHub kind of community forums that we publish on github.com. Going and engaging with folks on Twitter or Hacker News, any of the public kind of forums that are out there. Equally as important, probably maybe even more important, were the structured user research studies that we did. So, early on, for example, we used some, again, controlled experiments, but nevertheless kind of controlled observational lab studies to measure impact on essentially developer productivity and efficiency.
Yeah.
So, I'll be concrete about this. One of the ones we did, we asked a little bit over 100 developers, all professional developers with a minimum of 2 years of work experience. That classic interview question. Go create a web server for me using Node, right? And there were about 14 different unit tests that it had to pass. So I had to, understand what a 404 error was, had to understand what different types of responses were. And control group, treatment group. Control group, just their fingers and their wits about them, no AI assistance whatsoever. Treatment group, they had Copilot. And then we timed them. Basically, how long does it take you from the fork of the initial repo to check in with all unit test passing to complete the task? And what we found was that developers who were in the treatment group using Copilot, they were about 55% faster than those developers who weren't. So I forget the exact number, but developers using Copilot, it was just over an hour, like 74 minutes or something like that. Developers that were in the control group without Copilot, it was like 2 hours and 15 minutes or something there. And so, okay, that's great. Now we see that at least for task completion, that there is a real productivity gain. And of course, we then go back and we survey developers as well. Hey, what was your confidence level in the code that you wrote? How were you using it? How satisfied were you with the experience? Typical survey types of questions. Right? Then we would also follow it up with additional studies. So we had a study that was around code quality as well. This one, we took developers with a little bit more experience. So think 5 to 10 years of professional development experience. Again, control group, treatment group, half of them without Copilot, half of them with. And this time we asked them first to create an API, then submit that API or that code change in a pull request, and have another group of developers, similar experience, blindly evaluate the quality of the pull request. So they didn't know whether or not the pull request was generated with Copilot or without Copilot. But then we asked them across 8 different dimensions, is the code readable? Is it likely to be maintainable? Is it error? That kind of stuff. What was the quality of this code? And so in that one, across the board, across all 8 dimensions, the pull requests that were submitted using Copilot were of higher quality. Depending upon the dimension, about 10 to 15% higher quality as evaluated by human judgment, by the code.
That's great. Right?
The next kind of evolution of this has really been, and this is a lot of the conversations that I now have with engineering leaders, especially engineering leaders of very large teams. It's like enterprise scale teams who are adopting Copilot and integrating it into their engineering systems. And, they're, if you've got hundreds or thousands of engineers, the dollar value of those licenses does add up. And so they're asking a very reasonable question. Is there a return on investment here when measured in real world scenarios? Because it's one thing to say that Copilot confers a benefit in a lab setting. It's another thing to say that it confers benefit when in the real world, which is messy. There's changes in prioritization. There's changes in talent as people come and go. All the normal stuff that makes our job hard and worthwhile, right? And so kind of the next evolution of this has been, how do we conduct field studies with hundreds of engineers in the field? And so for that one, we actually just this last year wrapped up a 6-month study with hundreds of engineers. In this case, we conducted the study both with Accenture, so global large-scale consulting firm. And then we in parallel conducted a similar observational field study with Microsoft's internal employees. And for this one, what we had to do is again, there's a treatment and a control group. So
Yeah.
these are large enough engineering teams that there's always going to be someone who's not using Copilot and someone who is.
Sure.
Then we also conduct a same subject comparison. So when you're doing an A/B comparison, at the same time, developer A versus developer B in the months of January through June, let's say.
Mm-hmm.
When you're doing a same subject comparison, you take developer A and compare their behavior in January of June through, let's call it 2024, to July through December in 2023. So you're comparing them just against themselves.
The same, yes.
Yeah, totally. And so what we found there was that we actually are seeing some of the throughput and some of the velocity kind of impact that we saw in the field, in the lab studies. So specifically here, what we're starting to see is an increase in the number of pull requests that through the system. So if you consider each pull request like a unit of value delivered, right? There's like, hey, a feature was at least partially completed, a bug was fixed, a refactoring was completed. As a measure of throughput, the PRs, there's more of them per developer. So yay, good, yes, right? When you look at quality, we are seeing that a higher percentage of the pull requests are also being merged. Because in any large team, you're going to have some pull requests that just don't meet the bill for whatever reason.
Sure.
They never get merged. So at least as measured again by human review and human judgment, a larger percentage being merged. And then even more than that, it's kind of one thing to say that a human who is able to express critical judgment, but is also a human and therefore fallible.
Sure.
And so it's another thing to say, hey, is our test automation passing at a higher rate as well? You've got these these qualitative and these quantitative measures. And so we're also seeing that our CI success rate is going up as well in these studies. So what this tells me is that some of the early learnings that we gathered in lab studies are starting to translate into real world field observations.
Cool.
And also, we're so early in this transformation that I would call these all leading indicators. It suggests that engineering systems are, achieving higher throughput at least same, if not incrementally better quality, but there is so much work left to do. And that's great. Like this creates opportunity for everyone to go out there, to learn, to build from each other's knowledge, and to kind of keep this conversation going. Because we should all be practicing continuous learning and improvement, whatever changes we're introducing to our engineering system, whether they be, engendered by AI or more traditional DevOps changes.
Sure. That's really interesting. So how do you think about scaling your solution? You mentioned that you kind of started as an experiment, like probably a prototype or POC that was used internally. You started to build it up over time. How did all of this change once you actually started to scale? Like what changed? Did your team change? Did the technology change? Would love to understand what that transition looked like, because I'm sure it was a lot of change management.
Yeah, totally. Wow, that's such a big question. Because everything changed. So, remember that we started with a very, very small team. And in fact, Copilot got its start inside of kind of like a moonshot team inside of GitHub. So what GitHub calls GitHub Next. So, leaders like Ugo Damore, who's just an absolute visionary, led that team, and not everything that comes out of that team succeeds. In fact, by definition, a lot of the stuff that comes out of that team will never see the light of day. Is intended to be high risk, right? But this is one of those moonshots that did bear fruit. And so one of the first things that we had to do was, because that team is filled with researchers and folks who
Mhm.
are maybe intentionally building at prototype quality because
Yeah,
they got to go fast, they got to
of course.
experiment, and it's almost not designed to fail, but it
Mm,
is designed to only get to proving out the use
to
case, not
test
to.
it. Yeah, exactly. Yeah.
And so, where I really came into the picture was when we had achieved early signal of product market fit, and we were
Hmm.
ready then to move over into scale and productization.
Yeah.
That meant, one, that we had to create a transition plan, moving from research and prototyping to real engineering. And
Yeah.
please, I'm putting that in scare quotes if it's real only. Uh, Real scare quote engineering. And so, what we did there is we took a subset of those researchers and brought them over to the engineering team for a time constrained period of time, uh,
Hmm.
so that they could start to transfer some of their learnings, some of their knowledge about how the system worked. We scaled up the engineering team with more data scientists, more engineers, more folks, so that we could start to build a sustainable engineering product design, kind of try
Yeah.
around it.
Cool.
And then started engaging with a lot of the other folks who are absolutely necessary in order to build out a product, but aren't necessarily part of the engineering team. So that means folks
Sure.
like business planning and legal and our billing systems, right?
Hmm. Hmm.
Security, right? All those folks who, help us ship and deliver a scalable product with a little bit of not just safety, but like, I don't know, just product readiness.
Yeah.
Um, and that engagement, that was a full year of
Oh,
really
yeah.
building out those systems. And I'll say here that one of the, remember that this was 2021 to 2022 time frame roughly. Uh,
Hmm.
the world was still waking up and learning about what AI was, what large language models were.
Yeah.
There was a lot of, there's a lot of fear kind of in there, or at least a lot of trepidation, right? As folks were trying to make sense of what the technology meant, what its strengths
Yes.
are, what its weaknesses are. And it's not that
Absolutely.
conversation isn't still happening, but there's a lot more ambiguity out there, a
Hmm.
lot more headlines that were
Yeah.
generating interest. And so I would say one of the other big parts of that period, at least of my job, was going out there and engaging with legal, privacy,
Hmm.
responsible AI experts at GitHub and Microsoft to make sure that we were vetting all of our systems, that we were examining the technology from all sorts of different angles. I mean, we had,
Yeah.
oh my gosh, like reams of documentation and investigation were performed in order to evaluate, is there danger of these models returning back nasty comments,
Right.
just bigoted speech?
Yeah.
How are we ensuring that the code that's returned is of high quality? How are we
Hmm.
ensuring that the code that's returned isn't accidentally infringing on someone else's copyright or claim to ownership over code? And
Yeah.
so it was first engaging with all of those experts at GitHub and Microsoft, and then going
Hmm.
engaging with hundreds, if not thousands of experts outside of kind of our walls, the folks who
Yeah.
we hoped would eventually be buying the service, to
Yeah.
help them understand what safety protocols we had put in place. I'll
Hmm.
give just one example of that. And by the way, this is one of many, many
I'm
examples.
sure.
But one of them is we'll use copyright as one here, right? Everyone's
Yeah.
very concerned that Copilot might accidentally, even coincidentally, reproduce code that was out there in
Hmm.
the public domain.
Sure.
Now, I'll tell you, because we have telemetry on this. We do know that in a very, very small number of instances, it's a little bit under 1%, that Copilot can produce code that even accidentally looks like code that is out there in the public domain. I think of it this way: you give an infinite number of monkeys, an infinite number of types. As they say, eventually it's going to write Hamlet or Macbeth or something. So it's possible. Another interesting thing about it is that while just under 1% of suggestions do resemble public code, it actually doesn't happen evenly across all use cases. So it turns out that what happens is that when we get a match with public code, it is almost always, if not always, in an empty or a nearly empty file. It doesn't tend to happen in kind of existing business logic where you've got a lot of code surrounding it. So why is that? What's happening there? Well, so you got to remember that these models, they categorically, they have two sources of information for how they sort of probabilistically or statistically generate that suggestion. There is the model with all of the kind of probability that is baked into it from the original training data, right? And that's represented as model weights and parameters that are kind of feed into a series of kind of probability equations that happen in the model. And then there's the prompt itself. Now, in the case of Copilot, that prompt is kind of constituted from all the code that's surrounding your cursor location, right? So we're looking at code that's a little bit before and a little bit after the cursor and saying, oh, here's the context. Give me a prediction of what the developer would have written next. Now, the models place an outsized amount of bias on the prompt. That makes sense because you want a response from the model that is contextually relevant to whatever prompt is given. And so when you are in an empty or a nearly empty file, that prompt is thin to non-existent. And so all of the probability is being driven by that which is in the training data and in the original model weights and parameters. But when you're in existing application with lots of code surrounding it, well, now you got a big juicy prompt with lots of context. And so all of the, not all, but like the vast majority of the weight is going to be put on that context that's in the prompt. And so you're going to get back a solution or a suggestion that is tailor-made and bespoke to that context. And that never looks like, or at least, from it's a vanishingly small probability that you would ever be trying to solve the exact same problem, given a lot of surrounding business logic as anyone else. And that's why we almost always, when we see a match with public code, we it's because there's an empty file. Knowing that, we still didn't even want that to happen. So how do you build safety nets? How do you build kind of systems of protection into your product? In our case, what we do is we built out an IP filter that essentially takes every suggestion that the model produces, compares it up against an index of all the public code on GitHub, which, by the way, is like trillions of files. It's like bonkers. And so it's a freaking miracle of engineering that you perform that lookup. But we high five to all the engineers that made it possible. We do it. And so every suggestion that's produced over about 150 characters, by the way, there's no magic number at 150 characters. We wanted developers to be able to get like one-liner suggestions, and 150 characters is usually about 2 or 3 lines of code in most coding languages. And so that seemed like a reasonable minimum threshold. And no one's going to have a viable ownership claim over a single line of code. So that was how we struck that bargain, as it were. And so that is now baked into the product. And so scale is about, it's about building up your GPU capacity. It's about establishing SLAs and SLOs. But it's also about how do you build in resiliency and protective services around the models. Because a lot of folks, they think about generative AI as being all about the models. And
Right.
I got to tell you, like right now, the models are critical to it. And also the models are a fraction of the overall service that needs to be delivered. It is
Yep.
all the other systems that are around it that make it
Yes.
safe to use, just like any other piece of software that we would write.
Totally, totally. In that sense, as we see, our audience, which is startup founders, and as
Yeah.
they're starting to figure out how do they incorporate generative AI in their products, or how do they build products that rely heavily on this new AI technology and the models that are out there. What
Yeah.
advice would you give them as they're making that shift and they're trying to integrate this technology into their product?
Yeah. I mean, so I'm a product manager, so I tend to think about things in terms of use cases and value
Yeah,
differentiators, right?
yeah.
Um, so I would say, I think one, a lot of the conversation about from the last, let's call it 3 years or so, has been about how do you build a generative AI product? In other words, it's leading with the technology rather
Totally.
than leading with the what is the use case? What
Yeah.
problem are we trying to solve for our customers?
Yep.
And so I believe that, and I think we're starting to see some evidence in the VC kind of market that
Mm-hmm.
is starting to pivot a little bit. That folks
Mm-hmm.
are, it's less about building a generative AI
Yep.
company and more
Yep.
about building a, you know, knowledge-based management, customer support, legal contract review business, of which
Mm-hmm.
generative AI is a way that we deliver that solution.
Right.
So
That's great.
I would really think about first, like, how are you going to differentiate in the context of generative AI? So I
Yeah.
think there's a few places where companies are likely to differentiate. First, it's really going to be around, I'll call it speed of innovation and speed
Mm-hmm.
of experimentation, right?
Mm-hmm.
When you're working with generative AI, you need to be able to conduct experiments quickly in order
Yep.
to learn and to refine your product. We talked earlier a
Yep.
little bit about how we used experimentation to improve
Yep.
Copilot, you know, at a very quick pace in those first kind of years, but it's
Yep.
only accelerated as we've gotten more and more users and been able
Yep.
to conduct more experiments in parallel.
Sure.
So one of my predictions here is that going for market share over margin or profitability early on is going to
Mm-hmm.
be one of the ways that you get to quick learning, quick experimentation.
Yeah.
So that is going to be a big piece of it. Two, we talked a lot in the last 20 minutes or so about kind of IP protection, IP,
Mm-hmm.
kind of copyright protection, that kind of thing. Large language models, that is going to be it's going to be just like a prerequisite, I believe, for just about anyone who's using a SaaS kind of service.
Yes. Yep.
There's some kind of assurance built into it. And
Yep.
so that's table stakes, as they say. And that needs to be built in at both the technology level, but also at the contractual level as well. So, for example, in the case of GitHub and Microsoft, and I'm not a lawyer here, so don't take this as a contractual obligation, but they have built into the contracts essentially what amounts to indemnification or against third-party claims of ownership, right? Because we feel
Mhm.
so confident in the technical systems and the safeguards that we built in. But being
Yeah.
able to provide that contractual assurance as well is another big piece of it.
Hmm.
Uh, just like and again, I want to use scare quotes, in regular software, traditional deterministic software,
Yeah.
um, really your ability to compete inside of an enterprise or regulatory environment is going to be really, really important as well. Like there
Hmm.
are lots of instances where GitHub, historically might have been missing an important enterprise feature that blocked us out of or kind of disqualified us in a competitive bidding situation.
Sure.
Maybe we didn't support a certain identity provider. Maybe we
Yeah.
didn't provide a certain level of, something in our audit logs or a kind of a government certification of some kind.
Mm-hmm.
And so having the ability to deploy and operate in those different regulatory or security environments is going to be really, really important. Okay? Playing to AI's strengths, especially or large language model strengths at stage is going to help anyone. So its strengths tend to be summarization, explanation, pattern analysis, things like that. And so I tend to see at least a lot of the early participants being in things like knowledge-based management, customer service support, software development, legal contract review. There's some social media applications as well, marketing applications as well. Those tend to be the kind of industries that worked well for, again, summarization, explanation, things like that. And then probably last here, I probably want to put one more on it. I would say that anyone who can lead with evidence of real human impact in their product is going to have an edge, especially at a moment when, Lord have mercy, there's just so much hype in the system right now.
Oh, yeah.
Expectations are way up here. And if you can bring real evidence to the world and say like, no, like we've done our homework. We're not just selling a technology, but we're selling a solution to a problem. And it is, yes, it's achieved through this technology, but here is the actual human impact to it.
Exactly. So just going back to the basics, right? Delivering a product that people actually want and find value out of.
Yes.
Great. So one more question, because I know we're almost at time. How do you think GitHub Copilot is going to impact the future of work for software developers?
Yeah. A lot of ways. I mean, like we're genuinely moving into a new era of software development. I've seen a few of these inflection points in my career, roughly 1999 with the web, 2009-ish with both mobile paired with GPS and like some of the innovations that came there. That also happened to be about the time when DevOps was coming around. And so that really changed the way that folks developed. This is another one of those inflection points. On the long horizon, if you'll indulge me in a bit of futurism, I think we're definitely headed towards a world that is going to invite a lot more people to participate in the act and the practice of software development, because developers are going to start coding through natural language, right? If you think about this, what makes us great developers, it's not that we can speak Python, that we can speak Java or C# or whatever it is. Like, what makes us great developers is that we can take complex problems. We can break them down into smaller constituent parts. We can anticipate the failure points and kind of plan the contracts between systems, right? These are the kinds of, we can prioritize what is worth doing and what's not worth doing. These are the kinds of things that make us great software developers. And so, as we invite more people to apply that kind of like logic and that kind of architectural thinking to problems, invite a lot more people to participate in software engineering. And I suspect that the large language models are going to look a lot more like compilers. I mean, think about it. When you're writing with, I don't know, Rust today or whatever your preferred language of choice is, right? You're not writing the machine level language.
Right.
You're not operating in ones and zeros. You're working in an intermediate language. There's no reason why that language needs to be Rust or Clojure or JavaScript. It can be another language, and heck, why shouldn't it be German or English or right? So we're going to invite a lot more folks to participate. If I bring it in a little bit more close to the present, and I think about what's the next year, 2 years look like for developers, we've we've been using generative AI just in the code editor, really. Like basically been using it to write code a little bit faster than they would have otherwise. I mean, that's what predictive text means. It just predicts what you would have written yourself.
Exactly.
And yes, as we've moved into chat, we've been able to, ask a little bit more open-ended questions. How would you make this component more accessible? How can I make this API call more resilient? But it's been very limited to that which is in the file in front of you, or kind of the repository that's open in your IDE. One of the things that I'm really excited about, and I see already starting to change, is that we're starting to use the AI to reach out into more disparate parts of the application, the architecture. We're using it to go and collect context from the entire organization, from documentation, from issues and work items that describe the feature that we're implementing. Go out and to connect to a data warehouse that has telemetry about the live site issue that we're trying to resolve, the production database, that kind of stuff. And the more that we can ask questions about the entire application architecture, the entire engineering system, that opens up a whole world of possibilities for us as developers, not just writing code, but I tell you, most developers I know, it's a good week if you spend 25% of your time coding.
Yeah.
Vast majority of your time, it's reading other people's code. It's writing engineering design documents. It's planning for that next big thing that you're about to do in the code base.
Yeah.
And so we can start to kind of help accelerate that same throughput and accelerate the quality and invite more people to have conversations about the code for the other 3/4 of our work week. Hot damn, that is big stuff.
Great. That's amazing. Well, really appreciate the time, Ryan. Thank you for joining us. It was super interesting and fascinating to find out more about your world. So thank you.
100%. Thank you so much for letting me share what the team has been building. I had a lovely time.